Hapa nomba we look at the operation ya ma vibrators. Okay, now ngamwalolesha, okay, basically ngamwalolesha ama electrical schematics. Okay, ngamwalolesha ama electrical schematics mwala monati they're essentially identical. Okay, so we just focus on this part. Ukumuluta pali fidiko feni live and ya supply yuku after 4A5 and 4BE5, so it's really not much to stress about. Okay, but ngatuaponena ko punch pa no like so twalasangati muri position designation 4AE2. We'll just think of this as the earth leakage protection device 4AE2, similar to 4BE2. So these two positions essentially just earth leakage protection. Then ngatwaisa isapari 4AE3 na 4AE4. These are just thermal overload positions. Now ikwatama thermal overloads yabiri, in the sense that each vibrator has got two motors. Okay, so each motor is going to have its own separate thermal overload. The same thing applies to vibrator number 2 na ikwata 4BE3 na 4BE4. Okay, then thereafter tuakwata na selector switch. Now you can either select vibrator number 1, okay, which is on the left side, or select vibrator number 2, which is on the right side, but you can't run both vibrators at the same time. Okay, then thereafter tuakwate bati paddle switch. Now paddle switch ni limit switch fe yako bati as the crusher, or rather as the vibrators are feeding the material into the crusher bore, right? And then that crusher is of course putting that, or rather is channeling those crushed materials into like a bin beneath the crusher. Okay, and then depending on the level of the material mudi bin mudia, it's going to activate more like a limit switch kumulu kudia when the bin is full, and that's what we're going to be calling the paddle switch. So when the bin is full, where the crusher is basically channeling all these crushed materials, the paddle switch is going to be actuated, and then it's going to open this position. Okay, so the normal position is closed, and then when the paddle switch is actuated, it opens the path leading to the control yama vibrator coils, okay, power contactor coils, by way of 4AC1 or 4BC1. So the paddle switch essentially just de-energizes these power contactors, or it prevents you from running the vibrators when there's too much material in the crusher bins. Okay, so that's the paddle switch. Then after the paddle switch twakwata ne ibalela ndati motor number 1 isolator kwabana motor number 2 isolator. Okay, which is to say that ayama motor abiri na kwata ama isolators yabiri. Okay, it's going to look something like this. Nangola balela that motor number 1 isolator and motor number 2 isolator, but the vibrators will be controlled similar to this configuration. Yakobati twakwata isolator for vibrator number 1, designation for IS1, then twakwata na earth leakage relay for AE2, then twakwata na power contactor. Okay, power contactor designation for AC1. Okay, and then thereafter twakwata ma overload yabiri. There's overload 1 for AE3, overload 2 for AE4. Okay, these are basically one for each of the two motors associated with each vibrator. Okay, so this is what we have. So clearly it's just showing that there's just one power contactor for the two drive motors, but if we look at if we look at this, what are you trying to tell us? Okay, still just one power contactor. Okay, so basically that the two vibrator motors are controlled through a single power contactor, but each having its own separate thermal overload. Okay, why does this seem rather inconvenient? So because we're talking about two isolators, isolator 1, isolator 2. So if the two motors, two isolators, I would choose to think that we can have two parallel circuits. Okay, we can have two parallel circuits. These would be like two separate paths, as opposed to having a parallel linkage punch up. One path will be from the isolator, the earth leakage, the power contactor, to the thermal overload, to the drive motor. Okay, and so even the second motor for the vibrator will have the same configuration. So if we number, our key focus is just on this, the actual configuration of the power circuit. I've explained how I would rather it was. Okay, so tuamona kweva tiumu the same jazz. Okay, this section is just talking about protection, and then this is just talking about selection. The Part0 switch is also talking about protection, and then we can also argue to say that the isolators are related with the aspect of protection. Okay, and then thereafter the vibrator stop, and then the remote stop, that is, and then the vibrator local stop, and then thereafter there's the vibrator control interlock 282, and then there's the remote start, the local start, the cell-in contact 4AC1 related to 4AC1 power contactor, and then 481 is just a vibrator number 1 fault trip relay. Okay, and of course we've got the fault trip indication, and then the vibrator number 1 running indication, and then the configuration of this is essentially the same with this other one. So what we have said about vibrator number 1 also holds true for vibrator number 2. We're going to insert a function, or rather insert an object, but in this particular instance we're going to insert a function of block, and then the language is going to be ladder, and then this is what we're going to call vibrator control logic. Okay, that's what we're going to call this. And then of course we're going to ensure that and that multiple instance capability is marked in, and then of course we're going to do what do we do? Okay, so this is going to have multiple instance capability, and then we're going to insert a function. Okay, we're going to insert a function, insert object, insert function. Then we're going to call this as vibrator control. Okay, and then having called this as vibrator control, we're going to open the OB1, and then we're going to insert a network, and then we're going to call function 9 in this OB1. Okay, like so. And then we're just going to save this and then close this. The reason why we have done this, the reason why we're calling function 9 in OB1, because the instances of this vibrator control functional block, this FP1, we're going to call 2 instances of this functional block in function 9, and that because function 9 is already called in OB1, then that basically means our functional block is going to be processed. Okay, so that takes care of this. We're going to go back to FP1. We're going to open this. Okay, insert functional block, or rather code block. We don't have code block, so we can just open this object. And then before we do anything else, we're going to create the symbolic names. Okay, we need to identify protection inputs. So the protection inputs had memory bit addressing in the range of 2021. Okay, so we're going to say insert symbol, and the first symbol is going to be 4AE2, and then this is going to be vibrator 1, okay, earth leakage, vibrator 1, earth leakage. Okay, protection. Earth leakage protection. So we move on to the thermal overloads. Okay, so we get to this point, insert, because we're talking about protection still. So we go like 4AE3, and then 4AE4. Okay, so these will be vibrator 1, motor 1, thermal overload. Okay, and then for the other one would have something like vibrator 1, motor 2, thermal overload. Okay, which takes care of these two, right? And then thereafter, these are protection inputs. So 4AE3, and then there's 4AE4 protection inputs. Okay, so we've taken care of 4AE2, 4AE3, 4AE4. 4AD1 is a resultant condition. Okay, so this is vibrator number 1, 4th strip. So basically it's an output coil. So let's go to where we have the okay, let's limit ourselves to the inputs first. Okay, so we've done the protection inputs, and then the selector switch, the 3-position selector switch. Okay, as an ordinary input. So we go to where the inputs are, in this position right about there, insert symbol. So we're going to say come on, vibrator 1, select. Okay, insert symbol again. We have vibrator 2, select. Okay, so we've got vibrator number 1 select, vibrator number 2 select, maybe. So let's see, vibrator number, come on, vibrator number 1 select, vibrator number 2 select. So this takes care of this position. And then the powder switch is also a protection input. Okay, so we go to the protection addresses, insert symbol. So we go like vibrator powder switch. Okay, so let's say vibrator 1 powder switch. Okay, so we have vibrator number 1, vibrator number 1 powder switch. Okay, so which takes care of the powder switch as a protection input. Okay, and then we can also think of the motor isolators, like motor number 1 isolator, and motor number 2 isolator as protection. Okay, so what do we have? We come here, so we have vibrator 1, motor 1, isolator. Okay, so we have vibrator number 1, motor motor number 1, isolator, right? And then insert symbol. So the isolator I'm talking about is this one, motor 1 number 1 isolator, motor number 1 isolator, motor number 2 isolator. So again, copy this, paste there, vibrator number 1, motor 2. Come on. Motor 2 isolator. Okay, so which is IS. So we're going to copy this, paste there, vibrator number 1, motor 2 isolator, right? So that takes care of this position right there as protection inputs. Okay, and then thereafter we've got the remote stop and then the local stop. Okay, so these are normal inputs. So we go right about here. So we say vibrator 1, local stop. Do I need a capital L? Local stop. Okay, insert symbol, copy this, paste there, vibrator 1, remote stop. Okay, so we've taken care of the local remote stop, then the local stop. The local stop is actually 4AB7. Okay, 4AB7. Do we forgo this whole designation because we don't really have the equivalent of this? Okay, so this is 4AB7. So do we have 4AB8? I wonder. I don't really think we do. So this is 4AB7. Okay, so what I'm thinking is this is 4AB7, right? So maybe if we did this, okay, let's take this, paste in the comment section. Okay, and then we'll go like 4AB7-001. Okay, then cut this, paste there, then 4AB7-002. Okay, so basically all I'm saying is 4AB7-001 is the vibrator 1, vibrator 1 local stop, and then 002 is vibrator 1 remote stop. Okay, because we don't have the designation. Stop, local stop is 4AB7, but we don't have anything for remote, so which is why I've resolved to just do it like this. So this takes care of this, takes care of that, and then 282 has already been defined as the vibrator control interlock. Okay, and then thereafter we have remote start and then the local start as 4AC1. So we do the same thing. Okay, so as normal inputs, go, insert symbol. This is for what? This no. The start, the local start, and then the remote start. They have nothing associated with them. So what do we do with this? What do we do with you? Okay. What do we do? So let's see, vibrator 1. Okay, because we really don't have the designation, so let me borrow this. Okay, let me borrow this insert symbol. Okay, I'm going to borrow this. I'm going to paste there. I'm going to borrow this one here. I'm going to paste there, and then I'm going to call this as 4AB8. Okay, 4AB8, like so. And then of course one will be vibrator 1 local start. Okay, and then vibrator 1 remote start. Okay, now I know we don't have these 4AB8 001 002 in this, because as you can see here, there's nothing. I'm just improvising. Okay, I'm just improvising. So that's what we've done with this one. That's what we've done with that one. So that's as far as the normal inputs go. Okay, this is all the inputs we have. We've done the protection inputs, and then we've done the normal inputs. Okay, protection inputs, normal inputs, then vibrator number 1 select, vibrator number 1. Okay, so 1 select. Oh, okay, that's just that. And then now we deal with the outputs, right? With the outputs, we've got the vibrator 1 paddle switch operated. So as an output, the output addresses ended here. Okay, set symbol. So vibrator 1 paddle switch operated. Okay, so we have vibrator number 1 paddle switch operated. Okay, so V1 as vibrator number 1, P paddle switch, paddle SW switch or operated. You can do it whichever way you want, but this makes sense for me. So this takes care of this. Okay, but it's indication. Okay, that's what this is. Paddle switch operated. Okay, maybe IND for indication. Okay, I know it looks ridiculous, but that's as far as I can think of how to label this. So vibrator 1, I'm calling it vibrator 1 because even vibrator 2 has got a paddle switch. Okay, it's got this one here. So if you and vibrator 1 paddle switch operated indication, IND as indication. Okay, and then this takes care of this. Then to quarter for AC1 as vibrator number 1 on. So this is an output call. So we're going to insert symbol. This is going to be for AC1. Okay, so this is what vibrator number 1 on. Okay, which is for AC1, and then thereafter we are talking about vibrator number 1 fault strip indication, designation for AD1. Okay, we just write incorporating this for convenience, but we could even do away with this if we wanted. So as an output coil, it's in this position, and then this is what? This is for AD1. This is vibrator number 1 fault strip. Vibrator number 1. Vibrator number 1 fault strip, which is this 481, right? And then the indication. Okay, so we come here again for AH1. Okay, so vibrator number 1 4th strip indication. Okay, as an output coil. Good. So we've done for H1, and then the last one is vibrator number 1 running. So for AH2, okay, so we come here, so we have 4 AH2, okay, so this is vibrator number 1 running. No, anyway, I'll cut it. These are signs of exhaustion now. Okay, so vibrator number 1 running. So we've covered this part here. Okay, so basically we've covered all the inputs related to vibrator number 1. Okay, so we can do the same thing with vibrator number 2. Okay, so this is just vibrator number 2. So to start off, protection. Okay, protection addresses ended on memory bit 22.5. Insert symbol, and then we start off by saying 4BE2. So for AE2, vibrator number 1, earth leakage protection. So we need to copy this, 4BE2. So this is going to be vibrator number 2, earth leakage protection. Okay, and then thereafter we need another protection input, which is just 2, equivalent of 4A. Is it 4AE2 and 4AE3, or 4AE3 equivalent of 4AE3 and 4AE4, right? Except now we are calling them as 4BE3 and 4BE4. Okay, so 4BE3, 4BE4. So 4AE3, so we need the equivalent of 4AE3 need the equivalent of 4AE4. The reason I'm doing it like this, I need 4AE3, 4AE4. So I need this, I need it there, I need this, I need it there. But now we're talking about 4BE3, and then we're talking about 4BE4, and in the comments now we're talking about motor 2, right? We're talking about motor 2, like so. Okay, so it takes care of 4BE3, 4BE4, and then coming down, we've already dealt with the selection. Okay, as to whether you select vibrator number 1 or vibrator number 2, that's already been taken care of. And then thereafter we're talking about the Part011 switch. Okay, and then of course that's under protection. Okay, so the Part011 switch, vibrator number 1 Part011 switch, so we're talking about this one here. Okay, so we just borrow this. Okay, or maybe because we're talking about protection inputs, so let's come here, insert symbol, but we're going to borrow this one here. Okay, Part011 switch, and then going to copy this, except now this is vibrator number 2. Okay, vibrator number 2 Part011 switch, Part011 switch, right? So we've taken care of the Part011 switch, and then thereafter we're talking about the isolators. Okay, so view vibrator 1 motor 1 isolator, vibrator 1 motor 2 isolator. Okay, so again these are supposed to be protection inputs, so insert symbol, we're going to no I insert another symbol, and then going to copy this, then I'm going to paste there, except now this is vibrator 2, motor 1 isolator, and then vibrator 2, motor 2 isolator. And then of course I'm just going to copy the symbolic comments, then paste them there. What's wrong here? So memory bit 22, this is supposed to be 1, 2 and 3. Okay, so that takes care of the isolators. Vibrator 1, motor 1 isolator, vibrator number 2, motor 1 isolator, vibrator 2, motor 2 isolator. Okay, or maybe do we need to maybe put a dash to make it more readable? Okay, maybe a bit of but problem, we're not allowed to put spaces, or are we allowed? Oh, okay, so like this. Vibrator 2, motor 1 isolator, vibrator 2, motor 2 isolator. Okay, like this. Maybe like this is more clear. Okay, and then vibrator, I went in the wrong position. I need this, paste there. Vibrator number 2, motor number 1 isolator, vibrator number 2, motor 2 isolator. Okay, so this takes care of these isolators, right? Because we're talking about the second vibrator, of which there are 2 motors. So the first position is for the motor number 1 isolator, then the second position, motor number 2 isolator. So the way they have been done in this configuration, if these 2 motors are isolated, because we're using their normally open contacts, you won't be able to start the vibrators. Okay, unless of course the isolators are closed, and assuming every other condition is healthy or favorable, then you start your vibrators. So now we're talking about the remote stop and the local stop. Okay, which was 4AB7 if I'm not mistaken. So these are just normal inputs. Okay, so these are just normal inputs. We come here, insert symbol. I think I need four of these. Okay, I need 4 of these by way of 20.6, 20.7. This needs to be 13.0. This needs to be 13.1. This needs to be 13.2. Okay, I need 4 of these, and then I need to copy these. I need to copy these. I need to paste them there, and then I need to copy these comments. I need to paste them here. Except now we're talking about vibrator number 2, so where there's A in the first designation, we just put B and we're good to go. Okay, so what it is now is this is going to be B, and then of course this is going to be B, this is going to be B, this right here is going to be B, and then of course where there are B's, we're talking about vibrator number 2. Okay, we're talking about vibrator number 2, like so. So we've taken care of basically the remote stop, the local stop, Then remote start and the local start has been taken care of. Okay, and then thereafter we move on to the outputs, right? We move on to the output coils, of which as output coils go, we're talking about the powder switch operated. Okay, so we're talking about the powder switch operated. What else was common? We had 4AC1. We had 4AC1. Well, I'm just looking at this. Okay, we had 4AC1, 4AD1. Okay, so we have 4BC1, 4BD1, which is the equivalent of 4AD1. Okay, and then we've got 4AH1 and 4AH2, and then we've got 4BH1, BH2. So on the output side of things, okay, essentially we're just talking about these four. Okay, so we're going to insert symbol, insert. Okay, oh, come on. As outputs go, 105.3, 105.4, 105.5, 105.6. okay, as symbolic names go, we just copy these. Okay, we copy them, paste them there. Okay, we need to paste them right there. Replace the A with a B. Okay, because it is what it is. Okay, like so. And then of course they're going to have the same symbolic comments. Okay, they're going to have the same symbolic comments with the only edit being the vibrator number. So because now tulela ndapa the vibrator number 2. Okay, or tulela ndapo like so. So basically we've taken care of 4BC1, we've taken care of 4BD1, we've taken care of 4BH1, and then we've taken care of 4BH2. Okay, we've taken care of these. The only thing we haven't taken care of is the powder switch. Okay, so basically let's see, vibrator 1, powder switch operated indication. Okay, so we need a powder switch for vibrator number 2. So we're going to copy this here, paste there, edit this to 2, and then let's go back, get the symbolic comment, edit this to 2. Okay, so basically that does it for this symbolic name business. Okay, so we can close this now. Hopefully we've covered every other thing we could think of. Now, just to remind ourselves, this interface we're in, okay, let me just open this again. We're going to open FB1, the one we're calling at vibrator control logic. This we're going to open. Okay, this we're going to open. We're just going to look at, well, we won't even bother with with vibrator number 2, but our core focus will be just one of these vibrators, because Ngamwamona, their operation is essentially the same thing. Okay, and then we're going to do something that may be a little bit confusing. Remember, when we just started out, the need to have control over the protection inputs. Okay, in the sense that we needed to be made aware of any transition in the protection inputs. Kutiko tirimbi, it's not an actual operational state that has caused the input to change its state. Dimbi kudika loose wire fidia, chilenda chi machine kawaya kasela, then the system gets into this faulty state, chime na chi machine, kawaya kasela po, everything normalizes, and it gives you a pain just to try to resolve that issue. And when we did that, we were latching all the input conditions. Okay, we are just purely latching them. So because of the way the protection inputs were being validated, we can modify this to, we won't even bother with latching these protection states mukatium. Why? Because when these signals were being passed to the PLC and then the inputs were being validated, the protection inputs were being validated, just there, to normalize the system, we needed to reset those inputs. And it's only their state which are being used now, muri logic, yes. Right? For you to understand what I'm talking about, look at that section where we are talking about input validation. Okay. Having said that, we identify the protection inputs and the way they're used, the same reasoning as before. So we have 3 of these, and then on the input side of things, okay, we come to where in the interface in, you left click on the in section, and then on the right section where it says contents of environment or interface in, okay, first wala mbana earth leakage. Okay, we don't have access to use, okay, so we can just say earth leakage in the first instance, right? It's a boolean data type, okay, because that's what this is. It's just earth leakage, and then motor 1 thermal overload, motor 2 thermal overload. So in the next instance we have motor 1 thermal overload. Okay, I don't know whether we leave it like this. Do we even, anyway, I don't think I need this section. So do we have comments? Okay, maybe we won't need to see a lot of this, but need for us to see the comments. Okay, like so. So if I just say M1, can I just say motor 1 overload? Okay, and then maybe this one is just EL. In the comments we'll go like earth leakage, okay, like so. And then this is going to be comment motor 1 thermal overload, okay, which is this one here. Then motor 2 thermal overload, okay. So maybe let me just copy this, paste there. No. Then of course this is motor 2 thermal overload, okay. So we're talking about this one here, and then okay, we've gotten the earth leakage thermal overload, and then of course we're talking about what are you called, vibrator number 1 fault strip, okay, but I also need it to have a fault strip indication. Okay, so we'll just focus on this part first. Okay, so at the end of this we have fault strip. Okay, so what I'm going to do is I'm going to come to where it says static. Okay, I'm going to say static. I like saying 001, but in actual fact you can even say static 1. Okay, it's a boolean. Okay, so in this path where it says earth leakage, I'm going to get this here. So we're in this position, earth leakage coupled to the 2 thermal overloads. Okay, so we're going to have motor 1 thermal overload, and then we've got motor 2 thermal overload. Then we're going to pass that state to an output coil. Okay, which will, in this case, I'm just going to use the static. Okay, I'm going to say static, and then what I've done is the result of this. Okay, the result of this is being passed to this. I'm not really calling it 481. In this position, I'm going to use static. Okay, now because this is basically just protection related, I'm going to negate this. Okay, I'm going to negate this. I'm going to negate this. No, come on. I'm going to negate this and then pass the result to static. Okay, to static 01. I'm going to set a network, and then of course, what do we do? Normally open contact with static. Okay, and then I'm going to pass that state to what is being referred to as vibrator number 1 fault trip. Okay, so on the output side of things, okay, vibrator number 1 fault trip, in this particular case, we're just going to say vibrator fault, vibrator fault. Okay, can we get away with vibrator fault? Okay, maybe. Okay, so this we're going to call vibrator fault. Okay, so that's what we're going to call that. And this one, ladies and gentlemen, is going to be the general representation of this. Okay, we don't care whether it's vibrator number 1 or vibrator number 2. We're just going to say vibrator fault. Okay, which is this one here, and then of course there's also the indication. Okay, so this one we can just get away with just doing this, and then as an output we can do that, and then this is IND. Okay, this is IND, then this is indication. Okay, so this one here will come there. Okay, so this takes care of the fault strip indication. So we've taken care of 481, and then we've taken care of 4AH1. Okay, and then thereafter, what do we have? 4AC1 is not yet taken care of, so okay, so now because we know this section is all about protection. Okay, this section is all about protection. So we have another network, insert network. In this network, we're talking about the first thing is protection, right? So this is static, like so. So this whole thing, the state of this is passed on to a general variable which we are calling static. Now the reason I've chosen to use static in this, because if I'd chosen to define this particular one as vibrator fault or vibrator fault indication, I would have had to define it as an in-out variable, in which case it shows up on the input side and or not on the output side. So which is why I've chosen to use static. Okay, because these won't even show up on the interface of the final block call. Okay, they'll just be internally used. So this is why I'm doing it like this. So vibrator fault as a representation of 4AD1 or 4BD1, and then of course the VFLT indication as a representation of the fault trip indication. Okay, and then in this state, I'm saying the status of all of these is passed to static 001, and thereafter we've got the selection. Okay, so this one will be vibrator select. as an input. On the input side of things, we can say vibrator VS. Okay, in this case we'll say vibrator select. Okay, you can either choose vibrator number 1 select or vibrator number 2 select. It really doesn't matter. Okay, this we're going to paste there as vibrator select, so we're past this position. And then the other thing is the powder switch is also part of protection, like we previously said, and then the isolators. So let's see, static can also accommodate those 3 aspects. Okay, so we're saying on the input side of things, okay, we can also say the vibrator select, this and that. Vibrator select, I need to new declaration, and then we're saying powder switch, powder switch. Okay, what did we do with our symbolic table? What did we call the powder switch? Powder switch. No. Okay, powder switch operated indication as an output, but on the protection side of things, let's see U. Powder switch. Okay, maybe I need to put a dash there and the dash there, so it's PSW for powder switch. Okay, so PSW, which is fine. And then the other thing we're taking care of the powder switch, the isolators. Okay, so let's see, insert new declaration, another new declaration. Okay, so we've got motor 1 isolator. Okay, so and then this is motor 2 isolator. Okay, these are both Boolean. You can't see it, but they're Boolean declarations. Okay, so this one here is the powder switch, and then this one here is motor 1 isolator. Okay, this one here is motor 2 isolator, right? So these isolators, ladies and gentlemen, I'm going to just pick powder switch there, the isolator 1 there, isolator 2 there. Okay, because we said we're going to treat the powder switch as being part of the protection, the isolators are also as being part of protection, which you can easily see from the addressing. Okay, because if you look at the protection addresses, you find that the powder switch has got memory bit 23.1, which is the range of addressing for the protection inputs. Okay, and so even the isolators, it's the same thing. The range of addressing is those we chose for the protection inputs, which is why, in as far as the vibrator is concerned, these are part of its protection inputs. So that's why I've done them like this. Okay, so that now all these protection elements are actually part of this variable. Static, protection part, protection. So we've dealt with all the protection elements. We've picked essentially all the protection aspects in this section which were responsible for AD1. Okay, and then we've also added the isolators as well as the powder switch. Okay, so the only other thing we need now is this. Okay, after the protection, okay, then you select the vibrator select in this part. Okay, protect, vibrator select. So the only thing now is the remote stop. Okay, so remote stop externally, I'm not so sure, I've forgotten the normal state in factory IO, but I should think it's normally closed externally, momentary action, so internally it will be just normally open. So this will be as an input. Okay, as an input, it's going to be what? It's going to be local stop. Okay, so vibrator local stop. Okay, so this is going to be vibrator local stop, and then the other one will be vibrator remote stop. So get this comment, paste it there, and remote. Okay, remote stop. So we're there. So another one normally open. So vibrator local stop, then vibrator remote stop. So we've come all the way there, and then the vibrator control interlock. Okay, so this is vibrator interlock. Okay, so this is going to be vibrator control interlock. So this is a vibrator control interlock, VINT, and then this is normally open. Okay, so we have it there. It's vibrator control interlock. Then of course we've got the parallel branch in this position. Okay, so in that position, what we need, we've got what do we have? Normally open. We need a parallel branch like so, and then we need an output coil. Okay, so we need the local start, remote start. Okay, so here we have vibrator local start. Okay, vibrator local start STRT, and then vibrator remote start. STRT is just start. Okay, so the first one would be vibrator local start. Then this one is vibrator remote start. Okay, so now these two are basically just across from each other. It's a parallel configuration. Okay, vibrator local start, vibrator remote start, like this, and then we need an output coil. Okay, I'll go back to static, then I'll define another static variable. Okay, static 002. Again, it can be static 02, static 2, whatever you want, you can write. Okay, so static 2 will be the placeholder for this. Okay, then I'm going to insert a network, and then normally open. I'm going to get this variable here, paste it there, then get an output coil. This is what? Vibrator number 1 on. So we go to the output side of things. So we just say vibrator on. Okay, we don't care which vibrator it is, but this is just vibrator control. Okay, so this vibrator on will be this one here. Okay, so now we've taken care of the allocation for 4AC1. Okay, and then for 4AC1, what else do we need? We did 4-trip indication. We've done the 4-trip indication, and then 4-trip indication, vibrator running. Okay, so this one here, in as much as I think it's really not necessary, vibrator on indication. Oh. Vibrator on indication. Okay, like that. So we get this, create a parallel branch like so of an output coil, assign the address. So vibrator running indication. Ooh, it says vibrator running indication. What did we have? Maybe running. Vibrator running indication. Okay, vibrator running indication. So we've taken care of this, and then this. Okay, I know this is 4AC1 is responsible for vibrator number 1 running indication, but the other way is this. Okay, the other way we can do it is this. We can do this. Okay, on the input side of things. Okay, on the input side of things, we can say vibrator feedback. Okay, so vibrator, come on, vibrator power contactor feedback as an input, right? So that internally we have this right here. Get this one as vibrator feedback, paste it right there, and then get this output coil, paste it there, and then we're good to go. Okay, so that the indication that the vibrator is running is given by a feedback condition. Okay, so that's why we've done it like this. I'm sure now, I think this pretty much takes care of whatever this is. Okay, except the only thing we haven't done is the Part011 switch. Okay, so for the Part011 switch, operated, the Part011 switch is wired. Okay, Part011 switch has an indication. Okay, insert network. So internally we're using them as normally closed, because externally to the PLC they are wired through normally closed contacts, and then after input validation they are negated. Okay, so ideally it would be like something like normally closed, and then we negate. Okay, Part011 switch, we get this one here, and then no negate, and then Part011 switch operated, this indicator lamp. Okay, and then options, symbol table, what did we say as an output to Part011 switch? No, came right after. Okay, so part switch operated indicator. Okay, so what we need is this one here. Okay, and then on the output side of things, out part switch operated indication. Okay, maybe this thing here underscore. Okay, so part switch operated indication. Okay, and then get this one here, paste it right there. Okay, so we've also taken care of the part switch operated. Okay, yes please. So now this is what we have. It may look strange, but it does the same exact thing. Then the function blocks function vibrator control logic, we need to call this, and then this we're going to call db1. Okay, because I know, yes, I need to generate this. And then of course this might as well be vibrator 1. Okay, and then when we call another instance of this, okay, so this will be db2 data block, yes, and then this is going to be vibrator 2. Okay, so this does it. And then when it comes to assigning the addresses, okay, so what do we have here? So earth leakage for the first vibrator. Okay, so this is basically just vibrator 1. Okay, so earth leakage, we're talking about 4AE2. Okay, so we're talking about 4AE2 vibrator 1 earth leakage. Then we also talk about 4AE3, 4AE4. Okay, so 4AE, talking about 4AE3, and then we're talking about 4AE4. Okay, and then right after that we're talking about the part switch. So vibrator 1 part switch, vibrator 1 part switch. Okay, vibrator number 1 part switch. Okay, so the protection input takes care of this. Okay, isolator. Okay, so motor 1, is it vibrator 1 motor 1 isolator? Okay, so vibrator 1 motor 1 isolator, and then vibrator 1 motor 2 isolator. Okay, vibrator 1 motor 2 isolator, and then vibrator local stop. Okay, vibrator select. Okay, so this is vibrator 1 select. So vibrator number 1 select, and then vibrator 1 remote stop. Okay, vibrator 1, okay, vibrator 1 local stop, vibrator 1 with a 001 something. So this one, so vibrator 1 local stop. Okay, and then vibrator 1 remote stop, vibrator 1 remote stop. Should be this one here. then vibrator control interlock was 282. Okay, so 282 vibrator control interlock. And then what else do we need? Vibrator local start. So vibrator 1, that was AB8 maybe, AB8 1 and 2. So AB8 local start, then I think the other one was the same address but with a 2 attached. Okay, with the 2 attached, I think. So vibrator 1 remote start, and then vibrator feedback. Okay, because we really haven't assigned the vibrator feedback, so maybe in options symbol table as a feedback, does it qualify as a protection or normal input? Maybe just normal input. So on the addresses right about here. Okay, right about here. So we have vibrator 1 feedback. Okay, so we have vibrator number 1 power contactor, power contactor feedback. Okay, and then of course we know we're going to need the same thing, but this time for vibrator number 2 power contactor feedback, we're going to need another thing like that. Okay, for reasons explained earlier. Okay, so this is going to be vibrator number 1 feedback. Okay, that's taken care of like that. And then vibrator fault is clearly we're just talking about 481. Okay, so 481, and then for indication we're talking about 4AH1. This is 4AH1, and then vibrator running we're talking about 4AH2. Okay, this is 4AH2, and then which is this one now? Vibrator on. No, this one here is the indication. Okay, vibrator on is 4AC1. Okay, 4AC1 was vibrator on. Okay, and then bottle switch operated indication. Okay, so I don't know, vibrator 1 bottle switch operated. Can we go down here? Vibrator 1 bottle switch operated indication. It's this one here. Vibrator number 1 bottle switch operated indication. So basically this takes care of the first vibrator. Okay, then the second vibrator is basically the same thing. Okay, so we'll be talking about earth leakage. So 4BE what? 4BE2, and then we're talking about 4BE3, 4BE4. So 4BE3, and then 4BE4. Okay, then the powder switch, that's vibrator 2 powder switch, which is this one here, and then motor 1. Okay, so this is vibrator 1, vibrator 2, actually vibrator 2, motor 1 isolator. So in this vibrator 2, motor 2 isolator. Okay, then select, vibrator select. Okay, vibrator select, so vibrator 2 select. Okay, and then vibrator local stop, so vibrator 2 local, these were A, B, 4 what, 4B is 08 or something. So this is local stop, vibrator 2 local stop, 4BB7001, and then the same address, but with a 2 at the end. Okay, with a 2 at the end. And then vibrator control interlock is still 282. Okay, nothing has changed with that one. Local start, remote start, this is the 4 vibrator 2. Come on, local start is 4BB8001, local start, and then this one here, without me, the exception is just the 2 at the end. Feedback, so this is vibrator 2, if I'm not forgetful. Okay. Come on, what is the other one? Vibrator 2, V2FB. How come V2? Vibrator 2 feedback, 2 feedback. You're the one who made the mistake. We need to correct this. So no more inputs. It's vibrator 2. And then we might as well copy this because we don't want any more drama. Okay, and then on this other side, on the output side of things, this is what? This is a vibrator 4, so we're talking about 4BD1 in this arrangement. Okay, and then indication for BH1. Okay, for so 4BH1, V on 4BC1, 4BC1 as the vibrator on. The indication is 4VH2. Okay, that's 4VH2. Part switch operated indication, there's vibrator 2. Come on, vibrator 2 part switch operated indication. So vibrator 2 part switch operated indication. I think that's pretty much it. Takes care of everything. All we need to do is save, and we're done. If our assumptions, the simplifications that we have done, because the way we have done this one would be the same way we would simplify this. Okay, in the grand scheme of things, when we're talking about the hydroset, we said we're going to sell in, then also have this fault reset. But in Ghana Mumona, the hydroset thermal overload and the hydroset earth leakage protection, these are essentially just protection inputs. Okay, these are just protection inputs, and because of the validation logic that we created previously, this can work even without this. Okay, it can work without this, and it can work without that. Okay, it would work just fine, because to validate our inputs, we said any change in transition of the inputs needed to be accepted, meaning if it transitions from false to true, it triggers a fault in the system. Then for you to normalize, you need to reset that input. Okay, so this wouldn't be necessary to sell in at this point. It would just latch. It wouldn't reset even if there was a transition in the defining inputs.